Welcome to this lecture on Examples of Differentiability by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
So yesterday we did algebra of differentiability and chain rule, right?
Yes, sir.
Yes. Today we will do some examples for differentiability, right? So we will see some very good examples. Like if we want to have some differentiable function which is differentiable at limited number of points at any desired points, then how to get that example. So all those things we will learn today. Okay. Okay, so let us start with some examples of differentiability. So let me just share the whiteboard with you all. Okay, so is this screen visible to everyone?
Yes, sir.
Do some examples of differentiability. Okay, so we have already seen in one of our class that mod x is not differentiable, right? Fx equal to mod x is not differentiable at x equal to 0, right? We have already seen this, right? It is differentiable at all other points, but it is not differentiable at x equal to 0 and differentiable at every non-zero real number c, right? Yes. इसको प्रूव करा है हमने या नहीं करा अभी?
Yes, sir.
नॉट डिफरेंशिएबल का किए
अच्छा चलो कर लेते हैं इसको पूरा प्रूफ ही कर लेते हैं. लेट अस डू इट. सो प्रूफ. So we'll start with let C belong to R be any real number. Okay, so case 1, when C is equal to 0. So in this case we have to show that it is not differentiable. So we have to so fx equal to mod x क्या होता है अगर इसको define करोगे, this is x when x is greater than equal to 0 and minus x if x is less than 0. So keep this in mind. So now what will be our LHT? LHT will be limit, yes, h tends
Limit
to
s f of c minus h.
f of 0 minus h minus f of 0 upon minus h. This is limit h tends to 0, h positive, f of minus h minus, so 0 पे 0 है, this is minus h. This is limit h tends to 0, h positive, f of minus h, because h is positive so minus h is negative, so we will get this. So you will get h minus, sorry, h upon minus h, which is h gets cancelled, you get, so you get minus 1 here, right? So you get minus 1 here. Now RHT, again limit h tends to 0, h positive, f of c plus h, so 0 plus h minus f of 0 upon h. So this is limit h tends to 0, h positive, f of h minus 0 upon h. So now h is positive, so ये h ही रह जाएगा. This is limit h tends to 0, h positive, it comes out to be equal to 1. So LHT is not equal to RHT, hence the function fx equal to mod x is not differentiable at x equal to 0, right? Now case 2, c not equal to 0. So now we have to show that it is differentiable at c. So we will start with limit x tends to c, fx minus fc upon x minus c. Okay, so this is limit x tends to c mod x minus mod c upon x minus c. अब क्या होगा? अगर x c is positive, then x is positive. We can, or because we are approaching to c, so we can take x to be positive, and if c is negative, then we can take c to be x to be negative. ठीक है? So in either case, this will be, yes, क्या आएगा ये?
1x.
It will become mod of x minus c, जो भी डिपेंड करेगा. नहीं, लेकिन mod of x minus c लिखना is not a, इसको केसेस में ही करना पड़ेगा. We have to take the cases. We have to take the cases. Sub case 1, c is positive, then our x will be positive. So consider limit x tends to c fx minus fc upon x minus c. So this is limit x tends to c, it will be x minus c upon x minus c. C positive implies x is positive since we are approaching to c. So we can take x to be positive because we are working in a very small neighborhood of c, right? Because we are approaching to c, that means we are working in a very small neighborhood of c, so we can assume x is positive. Okay, is it fine?
Yes, sir. Yes, sir.
Okay, so this implies limit x tends to c equal to 1, so you get 1 here. Now sub case 2, c less than 0. When c is less than 0, then our x will also be less than 0, again because we are working in very small neighborhood of c, so we can have x to be negative अगर c negative है तो. So fx minus fc upon x minus c. So this is limit x tends to c, fx will be minus x, and this will become plus c upon x minus c. So you get minus 1 here, right? So in either case, we see that fx equal to mod x is differentiable whenever c is not equal to 0 and f dash x is equal to 1 if c is x is positive, right? And it is minus 1 if x is negative. So this implies f dash x is equal to signum function of x for all x not equal to 0, right? Is it right?
Yes.
f dash x is equal to signum function of x for every x not equal to 0. ये वाला ही ऑब्जर्वेशन हम कई जगह यूज भी करेंगे, so इसको याद रखना कि डेरिवेटिव ऑफ mod x is signum function of x provided your x is non-zero. At x equal to 0, it is not differentiable. Mod x is not differentiable. ठीक है? Is it fine?
Yes, sir.
Okay, now let us take the next example. Find a function that is not differentiable at x equal to 1, 2, and 3, and differentiable at all other real values. Guess what function we should take?
So 1 by x minus 1 into x minus 2 into x minus
1 by x minus 1, x minus 2, x minus 3. ये तो डिफाइंड ही नहीं होगा ना, कंटिन्यूअस होना चाहिए. ओके, एक और चीज ले लेते हैं. फाइंड अ कंटिन्यूअस फंक्शन। अब बताओ
So mod x minus 1.
यस mod x so fx equal to mod x minus 1 plus mod x minus 2 plus mod x minus 3. अगर in fact कितने भी finite number of points हो, you can always have such a function, right? Then example 3, let us write it. Find a continuous function that is not differentiable at exactly n real numbers. कौन से लेंगे हम?
So इसे ही n तक ले जाएंगे.
Yes. Let a1, a2, an be n distinct real numbers. ठीक है, so कोई भी ले लो real numbers. Then the function fx equal to summation I equal to 1 to n x minus ai is continuous everywhere on R and is differentiable at x if and only if x is not equal to a1, a2 and an, right? Yes. ठीक है, is it fine? So जितने भी पॉइंट्स अगर तुम्हें दिए हुए एग्जाम में तो उसको उसके हिसाब से यू कैन टेक द मॉडुलस फंक्शन और उसमें वो सब्ट्रैक्ट करके बना सकते हो. तो दिस फंक्शन इज नॉट डिफरेंशिएबल एट a1, a2 एंड an, राइट? Is it fine everyone? Is it fine?
Yes sir.
ठीक है,
Yes, sir.
और किसी एक पे प्रूव करके दिखा दोगे, बाकी सारों पे सेम लाइंस पे प्रूव हो जाएगा. सो इसलिए एक पे प्रूव करके दिखाना है बस तुम्हें. ठीक है, so give an example of a continuous function. Give an example of a continuous function defined on R which is not differentiable everywhere on R. So this is a very special function. Okay? तो इसको याद रखना है. Proof is not there in our syllabus. You just have to remember this function. Continuous function at every point but whose derivative does not exist anywhere. ठीक है, this is very special function. fx equal to summation n equal to 0 to infinity 1 by 2n cos 3nx for all x belonging to. So this is how you can define this function. So this function is differentiable. This function is the function f is continuous everywhere on R but its derivative does not exist anywhere. Okay, is it fine? Yes. So proof is not there in our syllabus. Proof of this example is beyond us. Is it fine? So just you have to remember this example. अगर आगे कोई मतलब इंटरव्यू में या कहीं पे पूछ सकते हैं, they can ask you this example. You have to remember this example. Fine, everyone?
Yes, sir.
Okay. Now let us do some more examples using algebra of limits, which we did yesterday. Example: show that for the differentiable function fx on R, fn dash x is equal to n fx to the power n minus 1 f dash x. Okay, so this we have to show. So how we will show this? Yes, how we will show this? Let gx equal to x to the power n for all n belonging to n, right? Oh, sorry, for all x belonging to R. So what will be the derivative of this gx? X to the power n?
N into x to the power n minus 1.
Yes, ये निकालना पड़ेगा हमें इसका क्योंकि
and
फॉर्मूला
x
में
minus 1.
let c belong to R be any real number. Okay. Now f to the power n is f to the power nx is equal to क्या हो जाएगा ये? This is your fx to the power n, right? And this is your g of fx, right? So fn dash x will be g of fn dash x see. This is c, then c. Yes. So what will be this? कल हमने करा है by chain rule. It is g of fc into
Oops.
f dash c by chain rule. Now we know that g dash x is equal to, this is n fc to the power n minus 1 into f dash c. Since g dash x is equal to n xn minus 1, right? So वो formula apply करके it comes out to be equal to this. So hence fn dash c is equal to n fc to the power n minus 1 into f dash c. So since c belong to R is arbitrary, it follows that fn dash c is equal to, oh sorry, fn dash x is equal to fx to the power n minus 1 dot f dash x for every x in R. Fine. So this formula we have used here. So this completes the proof. Is it fine?
Yes, sir.
So we have used the formula. Note: limit x tends to c, xn minus cn by x minus c is equal to n times cn minus 1. Right? So this formula is we have used here. ठीक है, ये फॉर्मूला यूज करें, इसको याद रखना। Okay, let us take one more example. For the differentiable function, okay, show that for the function fx equal to 1 by x, x not equal to 0, f dash x is equal to minus 1 by x square. Okay, for every x not equal to 0, hence deduce that for any differentiable function g on R such that gx is not equal to 0 for every x in R, 1 by g dash x is equal to क्या होना चाहिए, minus of g dash x upon gx square. ठीक है, this is what we have to show. Yes, how you will prove it, बताओ. First we have to prove that f dash x is equal to minus 1 by x square. For the function fx equal to 1 by x, we have to prove that f dash x is equal to minus 1 by x square. So let us start. So let c belong to r minus 0 be any real number. Consider limit x tends to c fx minus fc upon x minus c. So this is the limit x tends to c 1 by x minus 1 by c upon x minus c. So this is limit x tends to c, क्या आ जाएगा 1 by xc c minus x upon x minus c. So this is limit x tends to c minus of 1 by xc. So you get minus 1 by c square, right? So since c belonging to R is R, hence by definition of limit, hence by definition of differentiability, f is differentiable at c and f dash c is equal to minus 1 by c square, right? Now since c belonging to R is arbitrary, it follows that, yes, what we have from here, it follows that f dash x is equal to minus 1 by x square for every x in R minus 0, right? Is it fine?
Yes, sir.
Now we have to reduce this result. So इसके लिए क्या करना पड़ेगा, 1 by gx को we have to somehow bring it in the form of f, right? Now for any x belonging to R, 1 by gx क्या हो जाएगा, this is equal to 1 by gx. So this is equal to f of gx, right? Right?
Yes, sir.
So 1 by gx, so by chain rule, वन बाई जी डैश एक्स क्या हो जाएगा, एफ ऑफ जी डैश एक्स, राइट? एफ ऑफ जी डैश एक्स विच विल बी इक्वल टू एफ डैश जी एक्स इंटू जी डैश एक्स. And what is f dash gx? It is 1 by gx square. This is nothing but g dash x by gx square. Is it fine? Clear? So this is how you can prove it. So you can रूल इस तरह से डायरेक्ट मत अप्लाई कर देना इस पे 1 by gx पे, हमेशा ऐसे ही करके करना। कोई फंक्शन लेना फिर चेन रूल इस तरह से अप्लाई करना है फंक्शन के थ्रू, डायरेक्टली मत अप्लाई कर देना जैसे हम अपने 11th-12th में अप्लाई करते आ रहे हैं। ठीक है, सीधे यहाँ पे मत अप्लाई करने चले जाना gx के लिए कि पहले 1 by gx स्क्वायर कर दी, इस पे कोशेंट रूल लगा दिया, वो नहीं करना है। ठीक है, इज इट फाइन? यस, इज इट क्लियर? सो पूरा प्रोसेस इसी तरह से जैसे हम कर रहे हैं, पूरा उसी वही अप्रोच
Yes,
अप्लाई
sir.
कर। You have to use two functions. चेन रूल लगाने के लिए ये कॉम्पोजिशन ऑफ टू फंक्शन दिखाना है पहले उसे, देन यू अप्लाई चेन रूल। ऐसे नहीं कि डायरेक्ट जैसे हम साइन एक्स स्क्वायर का कर रहे हो डेरिवेटिव, तो जस्ट यू हैव अप्लाइड कि ये cos x स्क्वायर हो जाएगा इनटू 2x, इस तरह से नहीं करना है। ठीक है, यू फर्स्ट टेक टू फंक्शंस, एक fx इक्वल टू साइन एक्स लो, gx इक्वल टू एक्स स्क्वायर लो, फिर इसका डेरिवेटिव बताओ कि f डैश x विल बी इक्वल टू cos x एंड g डैश x विल बी इक्वल टू 2x, और फिर ये अप्लाई करो चेन रूल। ठीक है, इस तरह से करना है, डायरेक्ट नहीं करना है। चलो कर ही लेते हैं क्वेश्चन। एग्जाम्पल, फाइंड द डेरिवेटिव ऑफ द फंक्शन fx इक्वल टू sin x स्क्वायर फॉर ऑल x। तो क्या करोगे इसके लिए? फर्स्ट
दो फंक्शन होंगे।
hx इक्वल टू sin x फॉर ऑल x in R and gx इक्वल टू x स्क्वायर फॉर एवरी x in R, then we know that। ठीक है, डिपेंड्स, अगर ज्यादा मार्क्स का है तो प्रूव भी कर दो साइन एक्स का और इसका कि वो आएगा, और कम मार्क्स का है तो देन वी नो दैट कर दो। ठीक है, डिपेंड्स, अगर एक दो मार्क्स तक का है तो जस्ट राइट कि वी नो दैट, अगर 4-5 मार्क्स का है तो देन इसको प्रूव भी करो। ठीक है, देन वी नो दैट h dash x is equal to cos x for all x in R। ठीक है, and g dash x is equal to 2x for all x in R। now f for all x in R, fx is equal to, तो हो जाएगा, it will be h of gx, right? So by chain rule, f dash x is equal to h of g dash x, which is equal to h dash gx into g dash x, so which is your h dash is, so h dash x square कर दो into 2x, so this is cos x square into 2x। ठीक है, hence f dash x is equal to 2x cos x square for all। दिस इज हाउ यू हैव टू प्रूव। अगर 2 मार्क्स का है तो इस तरह से, अगर 5 मार्क्स का है तो इन दोनों को भी प्रूव कर देना है। ठीक है, ओके, इज इट फाइन?
Yes, sir.
तो चेन रूल इस तरह से अप्लाई करना है, डायरेक्ट ये यहाँ पे डायरेक्ट मत कर देना, ये पूरा प्रॉपर चेन रूल दिखाना है कि यू आर अप्लाइंग चेन रूल।
सर एक बार साइन 1/x का शो
साइन 1/x का उससे करेंगे हम, चेन रूल से ही करेंगे उसको, उससे नहीं करेंगे, डायरेक्ट नहीं करेंगे। ठीक है, क्वेश्चन find the derivative of fx equal to sin 1 by x for x not equal to 0. ठीक है, because this function is not continuous at x equal to 0, right? So यहाँ पे क्या करेंगे, solution so let दो functions define करेंगे हम, कौन कौन से, let hx equal to sin x
H and G.
for all x in R and gx equal to 1 by x
1 by
for all x belonging to R minus 0.
0.
Then we know that h dash x is equal to cos x and g dash x is equal to minus 1 by x square. Right? Now fx is equal to h of gx, right? For all x belonging to R minus 0. So by chain rule से क्या आ जाएगा हमारे पास, f dash x is equal to h dash gx into g dash x. So this is cos 1 by x into minus 1 by x square, so which is equal to minus 1 by x square cos x. Fine. Is it fine?
Yes, sir.
इसको डायरेक्ट नहीं करेंगे sin 1 by x को, क्योंकि डायरेक्ट थोड़ा टफ हो जाएगा ये, तो इसको we will use chain rule only. Another example, let us take for the differentiable function fx function f on R, find the derivative of mod f. So mod f कहाँ पे डिफरेंशिएबल होगा?
R माइनस जहाँ पे f0 होगा,
Sir, signum function x पे.
Mod f where and also the domain of mod f dash. ठीक है, डोमेन भी बताना होगा. So let क्या करेंगे इसमें, let hx equal to क्या लेना होगा, mod x for all x in R. Then we know that h is differentiable on R minus 0, right? Yes.
Yes, sir.
Now mod f क्या हो जाएगा, is equal to h of fx. So by chain rule कहाँ पे mod f differentiable होगा, since h is differentiable on R minus 0, so this implies h of f is differentiable whenever fx is not equal to 0, right? yes, क्योंकि f whenever fx is not equal to 0, right? By chain rule. By chain rule, for all x belonging to R with fx not equal to 0, f dash x is equal to h of dash x, which is equal to h dash fx into f dash x. So this is nothing but, now h dash क्या है? Signum function of
Signum function of f.
right, since h dash x is equal to signum function of x for all x not equal to 0, right? Signum function of fx into f dash x. Okay, so this is the function mod x. So this is nothing but, you can have, this is equal to f dash x if fx is greater than 0, and minus f dash x if fx is less than 0. Okay, is it fine? So this is your derivative of mod fx. Fine?
Yes. Yes, sir.
Question. Find the derivative of the function f from R to R defined as fx equal to x square sine 1 by x and 0 if yes. How you will do this?
So left hand derivative and right hand derivative.
नहीं चेन रूल अप्लाई करोगे ना यहाँ पे you
सर
will have
3 फंक्शन ले लेंगे.
solution. So let hx equal to x square for all x belonging to R, right? Gx equal to sin x for all x belonging to R, और एक और function hg dx equal to 1 by x for all x belonging to R minus 0, right? Yes. तो by algebra of limits क्या होगा, कहाँ ये फंक्शन डिफरेंशिएबल होगा, x स्क्वायर sin 1 by x
R minus 0.
r minus 0 पे, राइट? क्योंकि देखो 1 by x इज डिफरेंशिएबल ऑन r minus 0, ठीक है? तो ये जहाँ पे डिफरेंशिएबल नहीं है तो फिर ये डिफरेंशिएबल नहीं हो सकता वहां पे. तो sin 1 by x is not differentiable at 0. So by algebra of limits या प्रोडक्ट रूल कह सकते हो, एंड चेन रूल, बाय प्रोडक्ट रूल एंड चेन रूल, by product rule and chain rule, h dot gok x, oh sorry, h dot gok is differentiable on r minus 0, and for all x not equal to 0, h dot gk dash x will be equal to, क्या हो जाएगा ये? Yes, this will be equal to h dash x dot
GOK.
gokx plus
hx into g dash kx into k dash x.
So this is your, ये प्रोडक्ट रूल से आ गया, ठीक है, प्रोडक्ट रूल, और अब चेन रूल लग जाएगा इसमें. सो दिस इज योर g dash kx into k dash x, ठीक है. What is h dash x? It is 2x, and this is sine 1 by x plus hx is x square, and ये क्या हो जाएगा, g dash kx cos 1 by x into minus 1 by x square. So you get is equal to 2x sine 1 by x minus cos 1 by x, right? So hence now since हमारा क्या था, f था ना, f is equal to h dash g of k on r minus 0. So this implies f dash x is equal to 2x sine 1 by x minus cos 1 by x on r minus 0, ठीक है. Is it fine?
सर
हाँ, yes.
सर बट एफ डैश जीरो हम लोग यहाँ से फाइंड करेंगे तो सर वो जीरो आ जाएगा, तो सर ये
Zero.
डिफरेंस
जीरो के लिए हमें लिमिट अप्लाई करनी पड़ेगी, डायरेक्ट नहीं कर सकते एफ डैश जीरो, क्योंकि यहाँ पे आप कैलकुलस नहीं लगेगा ना, यहाँ पे ये फंक्शन अलग है, नेबरहुड में तो फंक्शन ये यूज हो रहा है, ठीक है, बट वैल्यू एट जीरो इज दिस. सो अभी हम डायरेक्ट नहीं कर सकते, तो हमें लिमिट अप्लाई करनी पड़ेगी, ठीक है. So we cannot directly find about the differentiability of f at x equal to 0. So we will use epsilon delta, limit definition. We will use the direct definition of differentiability to see whether f is differentiable at x equal to 0 or not, ठीक है. ऑल्दो ये तुम्हें एग्जाम में लिखने की जरूरत नहीं है, तुम्हारे अंडरस्टैंडिंग के लिए, ठीक है. This you don't need to write in the exam. Is it fine? Simply you can start with x equal to 0 case. Is it fine?
यस सर.
Okay, so let us solve, consider. So consider limit x tends to 0 fx minus f0 upon x minus 0. So this is limit x tends to 0, क्या हो जाएगा, x square sin 1 by x minus 0 upon x minus 0. लिमिट x टेंड्स 0, ये क्या हो जाएगा, x sin 1 by x, एंड वी नो दिस लिमिट क्या होता है, ये
जीरो.
ठीक है, ये ऑलरेडी प्रूव करा हुआ है हमने, क्योंकि जब तुम अप्लाई, इसे भी एप्सिलॉन डेल्टा डेफिनेशन से करते हैं, x sin 1 by x, तो ये
थ्योरम से भी हो जाएगा.
हाँ, एक्सक्यूज थ्योरम से भी कर सकते हैं. सो ये तुम्हारा ये आ जाता है मॉड x, राइट, x minus 0 फॉर्म में. तो ये करा हुआ है हमने, इसलिए वी आर जस्ट यूजिंग दिस. Hence by definition of differentiability, कि क्या हो जाएगा, f is differentiable at 0 and f dash 0 is equal to 0. Thus f dash x is equal to 2x sine 1 by x minus cos 1 by x if x is not equal to 0 and 0 if x is equal to 0. ठीक है, is it fine?
Yes, sir.
So this is how you such questions. So this much is enough for today. ठीक है, you can solve more such examples from your exercise book. So bye everyone, have a good day.
Thank you, sir.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.